Hi, it's Mr. Mittner, and this is our first video for the biology classes at Castle High School. I hope this helps to review for tomorrow's quiz. It's about ecology, and if you look here, we have a food web, and all food webs start with basically one of two things. You either have this, which is photosynthesis, or sunlight provides the energy, and a plant with chloroplasts in its leaves can take the ingredients of carbon dioxide out of the air, and the carbon cycle, which we talked about, and water from the rain, and they'll make carbohydrates or sugars and oxygen gas. So that is the beginning of all terrestrial anyway, and most at the top of the ocean food webs. You've got plants, which are considered producers. And another word for producer is autotroph, auto making its own food. Now, the exception is at the bottom of the ocean where it's very, very dark and you don't get sunlight. We have lots and lots of life, and this is the bottom of the ocean here. And there you have chemosynthesis, where there's bacteria that can take sulfur-containing chemicals that come out of the mantle of the earth through the crust into the bottom of the ocean, and then they can use that to make their own food, also carbohydrates and oxygen, through a process similar, but they're not using sunlight. They're using chemicals, so it's a chemosynthesis. All right, so let's talk about different energy levels. Each one of these levels is called a trophic level, and sometimes it's represented as a pyramid. And the reason it's a pyramid is because at the bottom is where there's the most biomass, the most energy, and the energy is measured in biomass, not numbers, because sometimes the numbers are smaller if the mass of something's really big, like in a tree. In this case, the producer's grass, so there's going to be a larger number of those as well. And then we have grasshoppers. They're going to be the primary consumers. And then we have things that eat the grasshoppers, be secondary consumers. And then the tertiary consumers would be things that eat those. All right, and what I want you to notice is the biomass measured in calories or kilocalories is decreasing as I go up, and it's decreasing by a power of 10 because 90% of that is lost as heat or energy it takes to keep those things alive. So only 10% is available to the next level. So if we have 1,000 calories here, or kilocalories, at this level we have 100 kilocalories. The next level will be 10, and the next level would be 1. There's only 10% available. So there's a very limited number of trophic levels, feeding levels that you can go to. These are called producers. First things are primary consumers. They're always things that eat the plants, so they're also herbivores or herbivores. And then above them, these are always carnivores because they're eating things that eat something else. So they're eating either the herbivore or herbivore or another carnivore in this case. Everything that eats something else is also called a heterotroph. Hetero means different, and so they're eating something else. Plants, which are called producers, are also called autotrophs because they make their own food. Remember, trophic level, trophic means like a feeding level, so autotroph is like you make your own food through mostly photosynthesis and occasionally through chemosynthesis. Now, if we look at this pyramid, sometimes we can break that, or that's showing in a wider sense this food web. Now, food webs are more complex than food chains because this from one arrow to the next would be a food chain, but all of them intercombined in the ecosystem is a food web. And to know what level something's in, what trophic level something's in, all I got to do is follow the arrows. I find the plants and I follow the arrows. So one arrow away from the plants is a primary consumer, which is a herbivore, which they're eating the plants. 2 arrows away from the grasshopper on up to the frog, that would be secondary. And so if I go 3 arrows away, from the berries to the titmouse to the snake to the buzzard, that's tertiary. So all I got to do is count the arrows. The direction of the arrow is the direction the energy flows. So the thing that eats something else has an arrow going to it. Like the frog is eating the grasshopper. The energy from the grasshopper is going to the frog. In this case, the plantain is the producer or the autotroph. The grasshopper is the primary consumer, and the frog is the secondary consumer. And these are both heterotrophs. I hope that makes sense. Now, there's another level on this that we haven't talked about a lot in class, and that's here. When things die, they're not part of that normal food web anymore. So what we've got to do now is look at how do those dead things how does the energy from those, and hopefully it's not lost, how does it continue on in that food chain? And nature has a way to keep that energy going so it's not lost at all. We have decomposers here. This is a bracket fungus on trees. I go hiking with my son and we see these. Every time a tree's falling, we look for these. They help break down that tree, so now it's usable. It's just turned into detritus, which is decayed material that now detrivores, remember vor means eat. You have carnivores, herbivores, omnivores. Detrivores eat the dead decaying stuff. So once the decomposers break it down, they now can eat it. Another way is if I have dead animals that either died of natural causes or roadkill or been killed by a predator and then got scared away or didn't finish, the scavengers come and pick that thing clean, and so the energy still continues on. Now, we talked about a couple cycles also, and this is the carbon cycle. The big thing you need to know is there's a lot of ways things go to where we get carbon dioxide in the atmosphere. Volcanic eruptions, where we have tectonic plates that come together, and there's carbonate molecules or ions in the rocks, like calcium carbonate. They come together, those plates, and when one goes under, subducts, all that heat from down here heats those things up, and now we get a volcano, and the carbon dioxide is released out the top of this volcano here. All living things give off carbon dioxide as part of respiration. When we burn fossil fuels, we've got carbon dioxide going off into the atmosphere. So a lot of carbon dioxide. So what do we do with that carbon dioxide? There's two things that happen. It either gets taken in by the seas or by the trees. It takes in by the ocean. Now, unfortunately, if the ocean takes in too much, it lowers the pH, makes it more acidic, and that's bad for the life in the ocean. But the ocean does take in. Also, plants, not just trees, but all plants take it in as part of photosynthesis. Like remember back here, carbon dioxide comes in, and now we get carbohydrates as far as the beginning of that food chain. So that goes through, now that carbon goes through the food chain, and as it's getting processed by any organism on any level in that food chain, carbon dioxide's been given off as part of that respiration process. What we did talk about is that carbon dioxide in excess, when there's more than the plants and the oceans can take in, has caused our planet to slowly warm over time. And that's caused some problems that we discussed in class. So carbon dioxide is a natural part of the carbon cycle. If we have too much to where the seas and trees can't take it in, so now the cycle's got kind of a traffic jam up in the atmosphere, then the earth warms because it forms like a blanket and traps the heat into the earth. We also talked a little bit about the water cycle. The water cycle, where the sun heats up the ocean, and we got evaporation, and we get condensation in the clouds and precipitation and runoff. And in trees, there's a natural process where the water gets soaked in by the roots and they move up to the leaves. And then to keep that line moving, it comes out of the leaves of the trees, and that's called transpiration, so the water can keep going up. But you know that really well. That's the water cycle. You've been doing that since 3rd or 4th grade probably. What I need you to understand is that the nutrients like water and carbon and nitrogen and phosphorus, those things just keep getting recycled over and over again. However, energy is a one-way street. If we don't have energy from the sun to come in, we die off. So whereas as these cycles, we never lose those things. They just continue on. Energy's not lost, it's just converted into a form that's not usable anymore as heat in the atmosphere or whatever. So we can't use that again for food. But as long as the sun is shining on, then we get photosynthesis, which is the base of all ecological pyramids. Now remember, we got predator-prey relationships, and we had talked about those. If the eyes are on the side, it needs to hide. It's usually a prey animal. If the eyes are in the front, it needs to hunt. It's a predator animal. And we talked about how prey animals have adaptations like camouflage. We talked about mimicry, Müllerian and Batesian mimicry. We talked about all those things in class. And saw those slides. I hope this is helpful as a review, and that if you need any additional help, I'm always here in the morning. You can come see me 7 o'clock or later. I'm usually here a little bit before then on any given day. Good luck on the quiz on Friday, and I hope this helps. Thank you.